So today I'm going to present to you the Julia programming language. Now, as a bit of a background, where I'm coming from when I examine this language is I'm more of a classical programmer in that I use C, Java, and JavaScript. So what I'll be showing you today is some of the background on Julia, a few of my experiences, and the beginnings of how to use the language. So what is Julia? So Julia is a high-level, general-purpose dynamic programming language. It was designed as a kind of catch-all language to try and get some power and some speed into more typical numerical languages like Python. It's used for scientific purposes, numerical analysis. It's considered a mathematical programming language. And you can tell that by its syntax that is slightly different than other languages. It's a minimalistic core language, and what I mean by that is they've got a core for Julia written, and most of the functionality in Julia is using that core. So most of the functionality is written itself in Julia. And one of the big things with this language is it's a free and open source language, and that was quite deliberately designed from the start, in that anybody could use the language. Anybody could go and see how it's made, and of course, as some of the experiences we're having with Java right now, nobody owns it. So Julia itself is a fairly new programming language. It first came into conception in 2007, and its first release, the first, I guess, beta or alpha release was in 2012. The 1.0 release in 2018 saw a good spike in users. We are currently in the 1.11 release, which was released May of this year. They are currently working on 1.2 and projected release in July of 1.3 as they bring more and more features into the language. And this is just to show it is a language that is currently being produced. It is actively being updated. So it's not a dead language or a forgotten project, which seemed to be a bit of the fear several years ago. So big hype. So in deciding to use a language or deciding to learn a language is going to be a bit of a time sink. It takes time to learn it. It takes time to master it. So you don't want to waste your time doing this. So there's a bit of a I look at the hype around the language of Julia, and is it worth your time to learn? Or should you learn a more typical programming language like JavaScript or Python? And so there's some things that came about. First of all, here's a couple of articles. So these slides will be posted. So this is an IPython notebook. It'll be posted, and you can click on these links yourself later on. It's designed by MIT, and they are considering it the next big programming language, which of course they would. And it has joined the Petaflop Club. RedMonk and Tyobe programming indexes have highlighted it as a fast-growing adoption by developers. Now the next two articles, Why Julia is a Programming Language to Dominate Our Future, and the 10 Fastest Growing Programming Languages that Employers Demand, are articles concerning data science and the up-and-coming. Data science is more of a commercial platform now, and people are using it more and more commercially. And so languages like Julia and Python are going to become much more popular. 3.2 million downloads as of January of this year. And it was used to join the Petaflop Club using 1.5 petaflops, using 1.3 million threads, and a program called Celeste. And Celeste is written entirely in Julia and processed 178 terabytes of image data to produce a catalog of 188 million astronomical objects in just 14.6 minutes. It achieved the peak performance of 1.5 petaflops using 1.3 million threads on 9,300 Knights Landing nodes using the Cori supercomputer, which is a Cray XC40. And all links to that you can find in the slides later. So that just shows that it is being used, and it is being used for real projects. So moving on, some of the resources that you're going to want to find are, first of all, the download. Where are you going to go download it? And you can download it from the Julia website. It's an easy program to install. If you're installing it on your own Linux system, you can just put it in your /opt directory. If you're going to be running it on our clusters, it can be just run in your home directory under the home/bin directory and just run the executable there. It runs on Windows, it runs on Linux, and it runs on Mac. There are a number of editors available for it. Atom is a IDE, an integrated development environment, for which Juno has been written. So Juno is a plugin to Atom for using Julia. You can also use it on the command line with any text editor. And in this case, today, I'm using it in Jupyter with the Jupyter plugin. There's two good docs for it. There's the docs at the Julia website, and there's also a wiki book written introducing Julia. Both are free resources. So what is some of the features, some of the motivation for using this language? Like I said, it's a free open source language with a very liberal license. You can call Python functions using the PyCall package. You can call C and Fortran functions natively. You can call them directly. You don't need no wrappers or APIs to connect to C. It's got a lot of built-in linear algebra, random number generation, string processing, and array processing functions. It's compilable and it has just-in-time compilation, so you can use it in much the same way as JavaScript as a scripting language, or you can compile it and run it natively. It's got an interesting typing system. They've called it optional typing, in that you can use it with or without typing, which allows for easy programming and also multiple dispatch. So multiple dispatch being like operator overloading, function overloading, etc. And an interesting feature of this language is the UTF-8 support. This allows you to use Greek letters and such in the programming language itself, or in your code itself. And this was designed primarily because it was a mathematical programming language and makes it easier to transfer from paper algorithm to code algorithm. So first we're going to cover variables. We're just going to use all programming languages. You need to use a variable. And in here, so this is just an IPython presentation. So this is interpreted directly by the kernel. Just a equals 6 is how you make a variable. Output 6. You can reassign the variables. A equals 7, 7. There's print line as a function, very similar to other languages. We can print line A. We can also show. And these are just some of the functions that we're going to be using as we show you what's going on in the language. You can perform math on variables, so A is equal to A plus 5, the standard things you would expect to see in any programming language. There is, you can assign strings to variables, so even if it was previously, this is by the optional typing, A is now a string. That's fine, that's now a string. And you can see what the type of the variable is, and that it does actually have a type. It's just ignored if you don't need it. So type of A is a string, turn that back to an integer, type of A is an int. You can get values from strings to load into your variables. So with A is equal to parse, you tell it what type you want. We're going to go with a 8-bit integer, and we're just going to go, and A is 8, 18, and hopefully this will throw an error. There we go. So because it's not parsable, we've asked for an integer 8, so this does have a type. It's not, so it's not being put. And that's the basic variable. You find that pretty much in any language you use, and they're very similar in Julia. Moving on are your different types. So these are your basic types. These are your built-in types that are represented directly by some sort of bit representation on your computer. Now you'll notice there's int 8. 8 is 8 bits, 16 bits, 32 bits. Oh, I went to editing mode, etc. Integer 128, 128 bits, and big int, which is just a type for getting around precision problems. You'll notice there's also unsigned int 8, unsigned int 16, so on and so forth, and then float. Now float, there is no actual, we're going to fix that now, aren't we? There you go. There is no base float, there is an abstract float. And so you'll notice that there is an integer, and there is a float 16. And those are the base. So if you go with an integer, and I want to go if I want to force a value to it, so you can go to A16, and this will make your variable that type. So type of A is now int16. If we go with int, it actually defaults to int64. There is no default float. Floats all come from an abstract float. So it's kind of a loose, all int 8s can be, or all int 8s can be int 16s, can be int 32s, so on and so forth. And that's also fairly straightforward. Moving on to strings and characters. So string literals are delimited by double quotes or triple double quotes, which we'll get to in a moment. Julia supports most standard string and character operations that you're familiar with, and strings can be accessed in the same manner as an array. Julia, to note, is a one-indexed language. So that means we've given a string here, the alphabet. If we want to access it, we can access a character. The first one is S1, which is an ASCII character. If we go to S0, we'll get an error. Likewise, we can go to S10, and so on and so forth. Now you'll note that the strings, double characters, as is typical. Strings can have escape characters. So we'll put that to escape the quotations, which is a common one, and put a quotation into the string. However, triple quotes allows me to put things in directly. So there it is, it's still a string, but if I put a slash quotes in there, it's going to look at it. You can't escape from the triple quotes. Another benefit of triple quotes is you can do it in multiple lines. So if you want a multi-line string, usually if you got a built-in help or something or some such, you can put that as multi-line strings with your triple quotes. It'll interpret everything directly. Characters, as opposed to strings, have a single quote. So C, that's an ASCII, that's a Unicode character. Type of, we've covered. If you want to convert a character to an ASCII int, you just go int with the character. So you do the constructor for an int, and it'll tell you the ASCII code for that. If you want to go the other way around, you go char with the value. So you get B for 98. A couple of other things you can do, I'll go back to get my string back, with strings is, so accessing the indices, you've got S0, S1 we showed you, which is the first one, but you've also got Sn. So instead of going S to the length, just go end for the Z. You can go S and minus 1 to get the second last, and so on and so forth. You can also get a range. So if we go S2 through 10, it now takes a substring of their string. You can also go S2 through N. Let's go 10 to end, and that'll go from the 10th character all the way to the end character. You can also include a step. Now, just as a note, most of these things you'll find also in arrays later on. So we'll go characters 10 to 20, step 2, and it's every other character, or every other character for the entire string. There we go. So it's very quick and easy to manipulate strings. Another way of creating a new string is using the string constructor. You know, string constructor. Forgot my equal sign. There we go. So you can use double quotes, or you can use a constructor for the string. And the reason this is important is you can now do string concatenation using the constructor. So it will be red space B. And now we've got red balloon. So what we've done there, that's its variable length arguments. So we can put as many arguments in there as we want. And you can concatenate different strings. They can be static strings, or they can be a variable. You can also use the star operator in order to concatenate strings. So B is balloon again. So it will B is equal to red star space star B, and B is now red balloon. That's just the quick form of concatenating strings. Another thing is interpolation in strings, and you could be familiar with this as from Bash with the $sign operator. So we can give a variable a is equal to 6, b is equal to 10, and we want to have a string that says 6 is less than 10. So we'll go $a is less than $b, and it'll just put in the values for you. You can also do math inside the so inside the interpolation. Go b plus 5, and it'll do the math for you. Along with these strings operators, there are actually more string operators. So all of the typical math operators, less than, greater than, less than, equal to, equivalency and not equivalency, can be used with strings. So you can say s is equal to a, b is equal to b's, s equals a, false. S is not equal to a, true. S is less than, with his, what did I do there? Huh. You can check, I guess, we'll just do two static strings for this example. Is greater than, so on and so forth. There are also a number of string functions, which we won't cover all of them here. You can go look for them up in your own, but we'll just kind of cover how they work. And one example is find first. Find the first occurrence of a pattern in a string. So we got, get our alphabet back there. So find first. So this is the first function we've seen. Now, this is not an object-oriented programming language, so you're not going to be attaching these functions directly to objects, but you'll be passing objects in. So we'll find first where we look for CDE in string. It tells you the first occurrence of the string as a range object. So what is interesting about that, and we'll cover this a bit more later on, is if you look at the type of the return value, it's a unit range. So that's telling you it's an object of itself that's representing a range within another object. But to continue, if you want a regex, you'll simply add the R on the outside of the string, out of the outside of the quotes, and now you can go with a regex expression, CD or DE, and go 3 to 4. We'll make one that's not there. There you go, 4 to 5, and that's just quick regex. Another function that you'll may often use is occurs in. Do you want to know if it's there or not? Same general format. Length of s will tell you what the length of your string is. So we are also going to use, and this is going to be a bit of an introduction for later on, is we are going to pass a function into the find first. So find first. First we'll make a function. So functions in Julia are just function name, some argument list, we're just going to call it value in this case, finished with end, which I still use curly braces a lot, return if value is equal to a character G. We'll find first, which is a function built into Julia, pass in our function, pass in our string, and it'll tell us the first one is that it finds. There are also built-in function generators to do stuff for you, like value or compare or value of, which is far beyond the time that we have for this. So moving on, so we're talking about functions then. So functions, what are functions? Well, they're defined by the function keyword and terminated with the end keyword. By default, arguments are specified in order, the same as you would with C. However, you can have named arguments by using the semicolon and specifying a name. And you can also specify a default value. Ellipses are also used, are used to define a variable length argument list, and they will be defined last. We'll go through a bunch of examples of these. So the first one here, this function add, AB, this is a very basic function. You'll notice there is no return value. By default, the return is the last evaluation. The last evaluation is a is equal to b. If the last evaluation was b plus 5, it's going to be b plus 5. It's not going to be the a plus b. You can also use return in there to specify what you want to return. Here's one. We've gone add args. Now, this is a variable length argument list. And we've indicated that with the parentheses here. Sorry, the ellipses here. There's also a name in front of the ellipses, and that is what the array of arguments is called. So add args ... So that allows you to, in here, we'll iterate through the argument list and sum them all together. What we've done here is added a UTF character, a Unicode character, and we go /sum. These are built in. This is done by the IDE, so this is done by Jupyter, and it's just /sum. I think I used the wrong slash there. There you go. /sum tab, \sum tab. And there's other ones. There's alpha and so on and so forth. So you can use characters to more match the algorithms you put in paper. Sum it up and return the sum. So now we can go sum 2, 3, 4, get 9. We can add 1. It doesn't matter how many arguments are in there. We can have none as well because we're iterating through. It's 0, so on and so forth. You can have another argument in there, a. So if we go 1, 2, 3, that should be 5 because we ignored the a. So you can have a number of arguments, and then at the end you name your variable argument list. Function increment. What this is doing is we're actually going to pass in an array. We haven't specified, we just assume it is, and add all values to this array. What is interesting here is we've given it a named value with a default value. So with a name, so a named argument with a default value. What this will do then is when we call it, we're going to quickly make an array. One way of making an array is with collect. We'll cover that in a moment. We'll pass this into increment. We'll pass in our array without any value. It doesn't seem to want to print it. What have I done? That's the value. So there you go. I don't know what I typed wrong there. So there's your first one, the array as it was collected or as it was built, incremented without a value passed in, printed again, and then incremented. We can change the value, and in order to do that, you'll put in the argument name and the new value. So value equals 2, and now everything will be incremented by 2. You can change that as you see fit, and you can see that works. It goes up, down. Of course, we're putting it to the same array each time, so it goes up, then down. And note that a is always required, as it is not a named value. Quickly moving on. Another type of function is the anonymous function. So functions are what are called first-class objects. It is not unique to Julia, but it is in Julia. We'll change that as signed, because that's going to, as if it never happened. So they can be assigned to variables, it can be used as arguments, or they can be returned from functions. One example is the find first function we used earlier. And so instead of putting the find first as a function, we put the find first in as an anonymous function. So what you do is this is the passed in value, then this is the returned. So passing in a single C for a character and returning whether or not C is equal to B, and it will tell you the first value. Okay, well, believe it or not, it does. There's also another one we're going to move on to, since for some reason this is not, I'm not going to debug it because we don't have the time. There is the round function. So round is a function. Yeah, there we go. What I was trying to do is string is a reserved keyword. There's a good example. And you cannot reassign reserved keywords. Because string is a type, it's reserved. So we'll go back to S here. What we're doing is we're passing in the function, the anonymous function, compare character to B, into the string find first. The second argument is the string S, and it simply returns the index of which this first evaluated for true. Find first is a built-in function into Julia, of which there's a lot of them. One example is round. If you want to see all of the methods of a given name, you use the function methods. Put in the name of the function, round, out, not in a string, is round. You can pass in, and there's a lot of these functions available in Julia, is if you pass in round, you can pass in an anonymous function, and it will give you, so you pass in an array, 2.0, 2.3.102, so on and so forth, and you pass in round to the array, and we're going to pass that into map. Map is another function available. Round, comma A. And what that will do is it will apply the round function to all values in array A. To 1.03, let's change that to 3.2, let's change that to 5.6, and you'll see it makes more sense. And that's just an example of usage of anonymous functions and where you're going to see it most often applied. Some of the other things you have, and we're just going to quickly move through these, as you'll be familiar with them from other language, control flow. The first one is compound expressions. Compound expression is kind of a block expression that you might find between curly brackets in other languages. And it evaluates several sub-expressions in order. We are going to use the begin and end keyword. So Z equals begin, X equals 1, Y equals 2, and then it will return by default the last expression. It's very similar to a function, except that you're not saving it with an argument list of any sort. And that allows you to evaluate several things all at once. If you're familiar with the ternary operator, it's very similar. It's kind of compresses many expressions down into one. Conditional evaluation, the if then else. So this is control flow more typical to what you're used to seeing. And it's as intuitive as you would if you've used C, Java, or other languages. And it's just a matter of knowing what the keywords are. Now, we put it inside of a function called evaluate. If x is less than y, print something. Else if, which is a continuation of that you have as many else if statements as you like. And you can have 0 or 1 else statements. It doesn't have to have one. So it'll evaluate depending on which one is true. And in this case, is equal to y, less than, so on and so forth. Now there's an interesting little thing about conditional evaluations, that they are leaky. And that means that they do not have local scope. Variables defined inside the block, not the block, inside the block, can be used outside of the block, even if they weren't already defined. And this can create some issues at times. Now what will happen is, if you go, we are going to go print line A here. And we are only going to make A inside the first condition. A is equal to 5, say. So if you evaluate and they're equal, we have created an A. Oh, sorry, that's the array. A is equal to, A is not defined. If it's less than, A becomes defined. So you can see the problems with the leaky evaluation inside the difference. So there is no scope inside the if statements, and that's a little bit different than other languages. Now, Boolean operators, just quickly, these are what you'd be expecting as well. You have the and the or. if you have A is less than 10 or B is greater than 10, print it. There you go, woohoo. Change the value so you can see what they're doing. So A is equal to 11. It's not printing because B is not greater than 10. Move B greater than 10. It's what you would expect. And operators means that both have to be true. So in this case, A is not less than and B is greater than. Now, there is also a term called short circuit evaluation. And that means that if something ends up being true in the first statement, so for example, A is less than 10, it is not going to evaluate the second statement. Now, this is not always immediately apparent in a language, but I am going to use a block statement here to show you. So using a block statement, B is greater than 10. We're going to print. I'm just going to print something in here. We'll here semicolon 10. So it's going to be print B is less than. So this is a multiple statement. We've used semicolons to divide them. You see woohoo. You'll notice that the B did not evaluate. We'll put the A over 10. So it does not evaluate. Put the B less than. And you'll see that print here. And the reason that happened is because the first part evaluated the first time, and the second part only evaluated the second time. And that's short circuit evaluation. Quickly moving on, while loops, very similar. Declare your variable, while and end, which is the pattern for blocks, and it will evaluate as you expect. Now, there is also the break statement. If I is equal to 5, break. Sorry, that's me going back to Java. If I is equal to 5, break. So it stops it if when I is break stops the loop evaluation. If we get continue, we'll stop the current loop evaluation, but continue other evaluations. Not break, continue. Continue, end. And there you go, we've skipped 5 with the continue statement. For loop. So the for loop is a bit more versatile than other loops. The basic for loop for I from 1 to 3, print line I, is as you would expect. I to 10. Now you'll recognize these. This is a range object. I skip 2, or I step 2 to 10 will be every other one. You can also do 2 variables at once with J by just including it on the same line. So J for 2 to 5, print line I comma J. We're going to print it as a tuple, which we'll cover in a moment. Include my second parentheses, and away we go. And so what it's doing is it goes through and it does the double loop evaluation for you, instead of doing the messy multiple nested loops, which are really hard to read. Arrays. So I'm going to try not to focus too long on arrays, as I see my time is clicking down. But arrays have got gotten a lot of attention in Julia. There's a lot of functions and a lot of different ways of doing things with arrays. But what is an array? It is an ordered collection of values declared with square brackets and comma delimited values. They are variable length and can come in 1 or more dimensions. Often a 2-dimensional array will be referred to as a matrix. You'll sometimes see a 1-dimensional array referred to as a vector. So how do we use these things? So the simplest way to create an array is just with square brackets. There we've got a 0-element array. We can put elements into the array. This is just statically defining them. You can have floats in there. You notice so now it tells the type is float 64. You can also mix types. You can put strings and characters inside an array, and all that's fine. There is a 4-element array of type any. Everything in it. You can specify an array type by putting the type in front of the array. Declaration, and now we have an array. Forgot my equal sign. This is an array of type int32. Now we can only put ints into it. If we put a character into it, we will get an error. Oh no, it evaluated to the ASCII value. Let's put a string into it to get an error. There we go. Cannot convert from string to int, so you'd have to use parse. If you leave the commas out when defining an array, it will automatically make a matrix. This is a quick way of making 2D arrays. So there's a 2x3 array. You want to add another row. There you go. If you were to do at times 1, 2, 3, what you actually have here is a slightly different object and a bit of a gotcha, in that this is now an array of arrays. So the element within the array, seen here, is another array, which is different from the matrix we saw a second ago, which is actually an array with 3x3 dimensions. So, some of the things you want to do with an array. We saw before, collect is a way of making an array. It makes an array of values, it makes an array from a range. You can also make an array of a specific type. An empty array of a specific type using the array method. So you define the type within 2 curly brackets in front of the argument list. So in this case we will float 32, a special keyword undefined, and then the dimensions you want. So if you put 5, we should have, and now these are just whatever values were in memory. It's just 5 elements of floats. If you want a 5x5 matrix, you put 5, 5, and so on and so forth, and you can have as many dimensions as you like. If you would rather this be started with 0, you can use the 0 function. So, zeros. In this case, we're going to put the type inside the argument list, and then our dimensions. And you'll get a zeroed array of that type. You can, I do believe you can also have ones, and there's a few other constructors like that. If you have an array of a specific shape or specific number of values, so statically 1, you can reshape it into 1 so long as the numbers match. So there's a 6-element array, B is equal to reshape A, and then a tuple with your dim. So we're going to go with 2, 3, so it matches, and then it just takes the exact same values and maps them into a new array. More array stuff. There's a lot of array stuff. You can copy an array. It's another way of constructing an array with the copy command. So copy A. We'll just copy it. So now B is a copy of A. Often you'll want to know the length of your array. Length. Size is not length, but rather a tuple of the dimensions of your array. So if you've got an array of size 11, it'll be 11. If we went and created a matrix, we'll make a matrix instead. The dimensions are 2x3. So those are the dimensions, not the actual count. If you want to splice an array using splice, you go splice the array in n. So let's go back to our original array A. Now here we've got an exclamation mark in the function name. And that is just practice for in Julia that shows that we are making a change to the passed-in object. It's not a rule, it's not enforced, but it's just practice. Anytime they have a function that changes of the passed-in object, they will typically put an exclamation mark. So we want to splice the array A at position 4. There's something wrong there. Well, I've written down my notes for that wrong. There we go. That's arranged with place at position 3, place at position 4, so on and so forth. You can replace the values using splice by including it in an array after the fact. So we move those and we'll add these values in. And then the 789 was included into the array. You can add values to an array with push, which also has an exclamation mark. We add 5 to the end of it. You can remove values with pop. Remove value, or you can pop first. And there are many, many, many more array operators. Array construction continued. Construction and manipulation continued. So a couple of more. Count is equal. So is equal is a generated function that will be passed into another function. So it's a anonymous function. We'll make our array again. We will go count. And it will tell you whether or not that's in there. And you can pass whatever function you want. Oh, I keep hitting shift there. There we go. So on and so forth. Maximum is another one. Tell you the maximum value, the minimum value, so on and so forth. There are a number of array functions. This is just touching on some of them. Find, count, any, does it exist, extreme, find the extreme value, so on and so forth. But we'll move on. A few quick more things about arrays. Rand function will create automatic randoms. If you want rand in a matrix, include multiple dimensions. Tuples. Now I've made mention of tuple a couple of times here, and a tuple differs from an array in that an array is mutable and a tuple is immutable. It's used in a couple of different situations. It's kind of an argument list to a function, and it can also be used to return multiple values from a function. As opposed to the square brackets of an array, a tuple will be defined with parentheses. So just comment those ones out. Tuple is simply this. So like an array, but with parentheses. However, you can access it much the same way as an array. However, if you try and change a value, you'll get an error because they're immutable. Another thing you can do with tuples is it can have named values. So it's got the value 1, it's got the named value A, and the named value B, which is itself a tuple. If you show, so there, it's got the named value A, and the named value B. Which can itself, and you can of course add more, and they can be of any type, in this case a character, so on and so forth. So I've alluded, I'm just going to stop after this one, I guess, is the range object. So the range object is this semicolon type structure. So if I go 1, 1:10, that is a range structure. Type of 1:10, you'll see unit range. You can do a range and any starting index to any ending index. You can make an array quickly from a range by putting it within array parentheses. So that's a one element, or that's an array. There we go. Collect. Collect with the range will give you a quick array. You can put the step in there as well. You can even go in reverse order. And a range is used to define ranges and number sequences. The range function is used to create a range programmatically. So instead of doing the colon notation, we use the range function. The first value is your starting value. Now you can tell it where to stop with the stop. Or if you would prefer, you want a certain number of values in there, you can go length of 10. It will do a total of 10 values. So no matter where you start, there will always be 10. Notice that we return the range object to an R and then pass that into collect. Ranges are variables too. You can just, or can be assigned to variables as well. Now I'm going to stop there because we are at 10 minutes to, and quickly go over some of the other stuff that you may want to look into. What we're skipping here is comprehensions, which is a way of creating fancier kind of ranges. Structures and types still have to be looked at. Parameter types, there's quite a bit of information available in the documents that you can go through, including your own custom variable types, composite variable types, and exception handling, as well as built-in parallelism and message passing. So at this point, I will go and I see there's some questions showing up, and we will take some questions here before we run out of time.